Welcome back, everybody. In this section, we're going to talk more about slopes. So really just kind of continue that discussion we were already having back in section 2.3 and keep elaborating there. So the first thing we're going to talk about here in reference to slope are two types of pairs of lines, parallel and perpendicular lines. So not every pair of lines is parallel or perpendicular. So we're going to look at the examples of each so that you can recognize them. So for the first ones, two lines are parallel if they have the same slope. So for instance, they could look like this. Okay. Now what you're going to notice is that they never touch or intersect. So they will never touch. They have the same exact slope and they are parallel lines. So if you look around your room, you can probably find some parallel lines. I actually see some in the wall right behind me. If I look right here, see where I'm pointing? That bar right there, that wooden piece. If I look at the lines on either side, those are all parallel, right? Or even the railings I have behind me here, they should be all parallel, right? So they're not touching. They're going to be perfectly lined up with one another. I will note too, for vertical lines, technically they don't have a slope, right? Because the slope is undefined, but vertical lines are also parallel to each other. If you look at your floor, so I'm sitting near my kitchen, I have a tile floor there. Again, I can see those parallel lines running like lengthwise, right? With those tiles. So they are perfectly lined up and they're never going to touch and they have the same slope. Your perpendicular lines are going to be actually the opposite. So one would look like this maybe, and the other looks like this, and they're going to intersect perfectly at a 90-degree or right angle. So you have the perfect intersection there. So they are really like perfect opposites. So their slopes are what we call negative reciprocals. So what that means is that they are different signs. So one positive, one negative, and they are also flipped versions of each other. So for instance, if your first slope is 3/4, then your second slope is -4/3. So they are like perfect opposites if you're perpendicular. Not only are they reciprocals, but they are also different signs as well. And what happens is they intersect at a perfect 90-degree angle. And then for a neither pair, so maybe it's like this. What's going to happen is they do intersect, but not at 90 degrees. So not that there's anything, I don't want to say they're not special, but there's nothing particular about them. So they do intersect and they have some sort of, point that they're going to cross or touch, but it's not going to be at exactly 90 degrees. So they're not perfect opposites there. So here again, you just have those definitions kind of written out a little bit more formally. So as a note, vertical lines are also parallel to each other. I just make that as a side note because again, they don't have slopes like we're used to, but they would be parallel to each other. And then lines that are non-vertical are parallel, like I said, if they have the same slope, and then also different y-intercepts. All that means is that they're actually different lines, right? If they had the same slope and the same y-intercept, they're actually just one line. So they'd have to be two different lines. Now, for instance, these two lines are parallel, and we can check that by checking their slopes. So here, I'm already in that y equals mx plus b form. So I can see that my slope is 2. I can pick that one out right away. For this one, I do have to do some solving first. So remember, if you want to find the slope, you want to be in that y equals form. So here I am going to solve for y. I'm going to start by adding that 4x to the other side. And then I'm going to divide both sides by 2. And that, of course, means dividing each of the pieces by 2. So here I have 2x plus 4. And there is my slope, m equals 2. Now notice I do have different y-intercepts, right? That one was 7, this one is 4. So it just ensures that I actually have two different lines. It's not the same line here. And because you have the same slope, then you have those parallel lines. Now, again, more formally, two lines are perpendicular if and only if their slopes produce a product of -1. It means that their slopes are negative reciprocals of one another. So that's kind of another little fun tip. You can always check to see if the slopes multiply to -1. So here's the example I gave up here. If you take 3/4 and you multiply it with -4/3, you get -12/12, which is -1. So you do get that they multiply to -1 as well. So that's a nice check for perpendicular too. And again, here's just another example, -3/8, +8/3. So you have not only a sign change, but also that flipping going on. One other thing, vertical and horizontal lines are also perpendicular to each other. Again, I'm just throwing those in there extra because vertical lines don't really have a slope that we can talk about because they're undefined. But a vertical line and a horizontal line would be perpendicular to each other as well. So let's just do a quick example here. We want to determine if the following lines are parallel, perpendicular, or neither. So to do that, you really want to compare slopes. So if you need to, you may need to solve for y so that you're in that y equals mx plus b form. So let's try it. Here, y is almost by itself, but not quite. So I'm going to bring that -2 to the other side. And I have y equals 5x minus 2. Now I can see there's my slope. For this one, I have to bring the x to the other side. I have 5y equals -x minus 15. I do like to leave my x's first just so I stay in that nice mx plus b order. Then I'm going to divide everything by 5. So y equals -x/5 minus 15/5. Now there is a 1 here, so I can also write this as -1/5 x and then minus 3. Okay. So here my slope is -1/5. Notice these are perfect opposites, right? Because 5 is the same thing as 5/1. And then my other slope is -1/5. So I see a sign change, positive to negative, and I see that flipping. So these are actually perpendicular. Now, if you're not sure, you can always multiply these together. If you multiply them together, you still get that -1. So that's another way that you can check for perpendicular lines. Now, one thing to note, if you have lines that are neither, so just as I'll put some examples up here, they really have slopes that are not related necessarily. So maybe one slope is 3 and the other slope is -2, right? So they don't really have anything in common there. You do want to be careful though. So let's say one slope was 3 and one slope was 1/3. That's still neither. I know you're saying, okay, but I flipped it. But because I didn't also change the sign, it's not perpendicular. So you need to be careful. To be perpendicular, you need both of those changes. Or same thing here. Let's say my first slope was 3 and my second slope is -3. Again, I know the sign changed, but because I don't have that flipping, it's not perpendicular. So a neither is really any other combination of slopes that don't match one of the first two. All right, we're going to do some more work with writing equations here and then using this idea of parallel and perpendicular. So write an equation of the line passing through -3, 1 and parallel to the line whose equation is y equals 2x plus 1, and then express the answer in point slope form and then slope intercept form. So whatever the form is, just think about what you need when you write an equation. We did this a couple of videos ago. So to write an equation, the first thing you need is always a slope, and then you also need a point. Okay, now I do see the point, right? The point that I'm given is -3, 1. So I have that, and I need to find my slope. All I know here is that it is parallel to that line, y equals 2x plus 1. But remember, parallel means same slope. So what I need to do is find the slope of this line and then use that in my problem. So if I look at y equals 2x plus 1, I see my slope is 2 here, and I will use this in my problem. So now I have a slope, and now I have a point. My point is not the y-intercept, so I have to use that y minus y1 equals m times x minus x1 form. And then I'm going to plug in my 3 values for here. So y1 is 1, my m is 2, and then my x1 is -3. My negatives here will cancel, and this is my first part. So this is that point slope form. And now I do want to simplify that. So I'm going to keep going here. I'm going to distribute through. So I have y minus 1 equals 2x plus 6, multiplying that through. I'm going to add 1 to both sides, and I have y equals 2x plus 7. So that is my answer in the slope-intercept form. All right, let's try another one. Find the slope of any line. So this is same question, but in 2 parts. So first, find the slope of any line that is perpendicular to the line whose equation is this. So we're saying that we want the slope perpendicular to the line 4y minus, x plus 4y minus 8 equals 0. So what I need to do first is put this in the y equals form. To find the slope. So let's do that first. So I'm going to, let's see, we'll rewrite it. I'm going to subtract the x first. I'm also going to add the 8 to the other side because I want to get rid of both of those away from that y. Now I'm going to divide everything by 4. So I have y equals negative x over 4 plus 8 over 4. Don't forget there's a 1 there. So that becomes y equals negative 1/4 x plus 2. So our slope here is negative 1/4. Now, this is different than the last problem. The last problem I wanted parallel, so I just wanted the same slope. Here I want perpendicular. So to make this perpendicular, what you want to do is to flip it and to also change the sign. So we're taking the reciprocal and we're taking the opposite. So we're going to instead use m equals positive 4/1 or m equals 4. So when I have a question about parallel and perpendicular, the first thing you're probably going to need to do is to find the slope of that given line and then see what you need. If it's parallel, then you're just using that same slope. If it's perpendicular, though, you're going to take that slope and you're going to make those 2 changes. You're going to flip it. So here 1/4 becomes 4/1, and you're going to change the sign. That negative becomes positive. So the slope that is perpendicular is 4. Okay, so that's going to be our answer for part A. Now we want to take it to the next step. We want to write the equation of the line passing through 3, -5 and perpendicular to the line x plus 4y minus 8 equals 0. And then just be careful here. You want to express your final answer in general form. So whenever you write an equation, we need a slope and we need a point. Now the point here we have is 3, -5. Now the slope we actually already have because we already found the slope that's perpendicular to this line in part A. So I just kind of broke the problem into 2 parts here. So we found in part A. So we're going to use m equals 4 there. Now I do not have the y-intercept, so I'm going to use the y minus y1 equals m times x minus x1 form. And I'm going to plug in for y1, m, and x1. So my y1 is -5, my m is 4, and my x1 is 3. This becomes y plus 5. Now it asks for the general form, so you're going to keep simplifying here. I'm going to multiply through by 4. I'm going to keep cleaning up, so I am going to bring that 5 to the other side. I tend to just naturally go into that slope-intercept form because we use it so often. So you're just going to really just clean it up. And then just remember that general form looks like this. It's ax plus by plus c equals 0. So it's all on one side. Everything goes to one side. So here, we're almost there. If I can just get the y over here, then I have everything on one side. I have that 0 equals 4x minus y minus 17. And again, if you don't like having that 0 on the left side, it's perfectly fine. So what you can do is just rewrite it. I'm going to go ahead and do that. 4x minus y minus 17 equals 0.